In this lesson, we will explain how polymers are made, and discuss the history of polymer and plastic developments. Polymers are very large molecules made of a chain of many smaller molecules linked together by covalent bonds. The small molecules that are used to create polymers are called monomers. Polymers are organic compounds that contain the elements carbon and hydrogen, but may also contain oxygen, nitrogen, phosphorus, sulfur, and other elements. Polymers form when chemical bonds link large numbers of monomers together in a repeating pattern. It's helpful to think of polymers like chains of many paper clips connected together. This is why chemists often call them polymer chains. Each paper clip would then represent a monomer molecule, as shown in the diagram. When two different monomers combine, they form a copolymer. In this diagram that uses the paper clip analogy, one monomer is represented by the green paper clip, and the other by a red paper clip. There are different types of polymers. Polymers that occur in nature are called natural polymers. Cellulose formed in trees, plants, fruits, and vegetables are created from small sugar molecule monomers. Silk and wool are produced by animals. Proteins are created in the human body from small monomer molecules called amino acids. Glycine is the simplest of the naturally occurring amino acids. Its structural formula is shown in the diagram. Polymers that are man-made are called synthetic polymers. They are formed into many of the products we use in our daily lives. Among these are polymers formed into plastic bottles, storage bags, toys, automobiles, and many other items. Polymers formed into fibers are used to make clothing and carpets. Polymers are also used to create adhesives used in glue and even chewing gum. There are thousands of products made today that use one or more synthetic polymers. Synthetic polymers formed into plastics can be divided into two categories. The first category is soft plastics, which are called thermoplastics, because they can be melted into a thick liquid, and reformed into a new item. Polyethylene is a soft polymer used in squeeze bottles, and toys. Nylon, and polyesters are soft polymers used in clothing. Polystyrene is used in cups and packing material. Polytetrafluoroethylene, commonly known as Teflon, is used to coat the inside of pots and pans to create non-stick surfaces. Hard plastics are the second category of polymers. They are called thermosetting plastics because once they are formed, they cannot be remolded to form a new item. Consequently, they are mainly used for high-temperature applications like handles for pots and pans. Another hard polymer is polyvinyl chloride, commonly used for pipes and other products. Sometimes hard polymers are recycled by grinding the material into small particles for use in composites, which we will cover later. Synthetic polymers like polyester and nylon are extensively used today to replace natural polymers like wool, silk, and cotton for clothing. Synthetic polymers have made possible many new products, such as DVDs, and lightweight computer cases. Now, let us review some of the history of polymer development. In 1839, Charles Goodyear developed a process called vulcanization. This process enabled soft, gooey, natural rubber to become a hard, stretchable polymer that was used to make bicycle tires, and later automobile tires. In the vulcanization process, the long polymer chains are connected together from their sides like a chain link fence. Today, this process is called cross-linking. In the diagram, which again uses the paper clip analogy, the red paper clips represent the cross links. In 1856, Alexander Parkes reacted nitric acid with naturally occurring cellulose to create cellulose nitrate. The structural formula for the polymer is shown in the diagram. The subscript, N, indicates that the structure in brackets continues in the long polymer chain. John W. Hyatt made modifications to the process in 1869, and developed a cellulose nitrate product called celluloid. Eventually, celluloid was used to make the first movie film. In 1838, Henri Renault created polyvinyl chloride by shining sunlight on vinyl chloride. However, he never developed any products with the material. It was not until 1872, when Eugen Baumann repeated the experiment to create polyvinyl chloride. The diagrams shows the reaction. It is the ultraviolet light from sunlight that caused the polymerization of vinyl chloride. PVC is made by a different process today. The next major development was made by Leo Baekeland in 1909. He invented a hard synthetic polymer by combining phenol and formaldehyde. This polymer would eventually be called Bakelite in honor of its inventor. This diagram shows the structural formula for Bakelite, which is a cross-linked polymer. Note the CH2 groups that link the two chains together. This cross-linking is what makes the polymer rigid, and gives it high strength, and high temperature resistance. Bakelite was used to make the very first telephones. Friedrich Klatt patented an improved process to make polyvinyl chloride in 1913. This led to the first products. PVC was used to make the first long-playing audio records in 1948. These were called LP records. Another major discovery was the invention of what are called acrylic polymers. During the years from 1928 to 1930, a number of chemists in the United States and Germany developed a polymer called polymethyl methacrylate. The polymer is known by several trade names including plexiglass, lucite, and acrylic plastic. Using various methods, polymethyl methacrylate is made from a vinyl ester called methyl methacrylate. This diagram shows the structural formulas of both the monomer and polymer. Again, the letter N shows that the formula in brackets repeats many times in the long chain polymer. Acrylic polymers have the property of being highly transparent. This makes them ideal for products such as sheets, tubing, cabinets, windows, and even furniture. An important discovery in the history of polymer development was the invention of polyethylene in 1933 by chemists Eric Fawcett and Reginald Gibson in England at Imperial Chemical Industries. Polyethylene was first made by applying high pressure to ethylene. The reaction is shown in the diagram. By the early 1940s, factories were established to make polyethylene, and many products were developed over the next 20 years. In 1949, polyethylene was used to make a broad line of popular food containers with the trade name, Tupperware. Polyethylene food containers are in wide use today. Today we use many additional products made of polyethylene including bottles, tubing, storage bags, and flexible sheets.
The invention of nylon was another milestone in the history of polymer development. In 1934, Wallace Carothers developed nylon at the DuPont Company. Nylon was then used to make fibers, and woven into cloth that became a substitute for naturally occurring silk. Nylon is a copolymer formed by adding one monomer with two diamino groups to a second monomer with two carboxylic acid chloride groups in the presence of a base like sodium carbonate. A diamino group has a nitrogen atom bonded to two hydrogen atoms. A carboxylic acid chloride group has a carbon atom double bonded to an oxygen atom and single bonded to a chlorine atom. The chemical reaction to form nylon is shown in the following diagrams. The first monomer is called 1,6-diaminohexane. It has a diamino group on the number 1 carbon atom on the right, and another on carbon number 6 on the left. The second monomer is called sebaceoyl chloride. It has an oxygen atom and a chlorine atom on carbon number 1 on the right. This is called an acyl group. A second acyl group is on carbon number 10 on the left. The diaminohexane is dissolved in water containing sodium carbonate, and is added to the sebaceoyl chloride dissolved in hexane. Because the hexane solution has a lower density than water, it floats on the water. But the reaction takes place very rapidly at the interface between the two solutions where the nylon is formed. The diagram shows the structural formula for a section of the nylon polymer chain. This particular polymer has the name nylon 610, because it has repeating sections of 6 and 10 carbon atoms. The formation of nylon 610 fiber is shown in the following video. Note the way the fiber is drawn from the interface between the two solutions. Gloves, jackets, playhouses, and rope are just a few examples of the many nylon products in use today. Another important polymer development was the invention of polyurethane in 1937 by German chemist Otto Bayer. Polyurethanes are copolymers formed by reacting one monomer with two isocyanate groups, and another monomer with two alcohol groups, in the presence of a catalyst. A hydroxy group has an oxygen atom bonded to a hydrogen atom. The formula for a dihydroxy group compound is shown on the left in the diagram. An isocyanate group has a nitrogen atom double bonded to a carbon atom, which is also double bonded to an oxygen atom. The formula in the right of the diagram shows a diisocyanate compound. When the two monomers are reacted together, the polyurethane is formed. The structural formula is shown in the diagram. The properties of the polymer can be tailored to fit a specific application by changing the number of carbon atoms in each monomer. The formation of a polyurethane foam is shown in this video. Polyurethanes are widely used in flexible foam seating for furniture, car seats, insulation, surfboards, seals, gaskets, and adhesives. In 1938, DuPont chemist Roy Plunkett accidentally discovered polytetrafluoroethylene when he opened a cylinder of tetrafluoroethylene gas and no gas came out. After he cut open the cylinder, he found that it contained a white powder, which was the polymer that he called Teflon. Very durable, and heat-resistant, Teflon also has the property of resistance to adhesion. This makes it ideal as a coating on the inside of pots and pans to prevent food from sticking to its surface. Teflon is made by polymerizing tetrafluoroethylene using various methods including pressure. The structure shown in the diagram is similar to polyethylene except that all the hydrogens are replaced by fluorine. Another important development was the invention of ABS polymer at the Borg-Warner Corporation in 1948. The name is derived from the fact that it is made from three monomers, A, acrylonitrile, B, butadiene, and S, styrene. This type of polymer is known as a terpolymer. This diagram shows the reaction of the three monomers and the structure of the ABS polymer. The properties of the polymer can be tailored to fit an application by changing the proportion of the three monomers. ABS is widely used today to make millions of products from Lego pieces, to golf club heads, musical instrument cases, car components, and piping, just to name a few. From 1946 to 1953, many other polymers used in today's products were developed. Included among these are polystyrene, Dacron, which is polyethylene terephthalate, Orlon, a modified polyacrylonitrile, polypropylene, and Lexan, a polycarbonate. In 1965, a copolymer called Kevlar was invented by Stephanie Kwolek at the DuPont Company. The chemical name for Kevlar is polyparaphenylene terephthalamide and it is made by the reaction shown in the diagram. Kevlar is made by reacting phenylene diamine with phenylene diacid chloride. The general name for this type of polymer is a polyamide. Kevlar is 5 times stronger than steel, so it is widely used in bulletproof vests worn by police officers. It is also used in protective suits, gloves, and shoes for firefighters due to its fire-resistant properties. The development of new types of polymers is continuing. Today, scientists are making displays with light-emitting diodes based on organic compounds and polymers. This has led to light-emitting displays for cell phones, and small televisions on flexible film instead of rigid surfaces. These photos show a Samsung flexible display, and a Sony television with a thin film display. Polymers are also used to make composites. A composite combines 2 or more materials to form a new material that has different and improved properties. Many composites are composed of 1 or more polymers. Wood is a naturally occurring composite that consists of long fibers of cellulose, held together by another natural polymer called lignin. Together these two polymers form very strong tree trunks. Many products made today contain composites. Fiberglass composites combine glass fibers woven together and strengthened with a polymer material such as a polyester. Fiberglass composites are strong and hard, so they are widely used for automobile bumpers and boat hulls. Composites that combine synthetic polymers with the graphite form of carbon are so strong and flexible that they are used in golf clubs, fishing rods, and tennis rackets. This presentation was produced as a public service to help middle school and high school science teachers develop experiments, presentations, and demonstrations that can be used in their classes. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.